Oppan Gangnam Style. Gangnam Style.
Hello everyone, today we're going to be starting Unit 5. We're going to look at some more tools and strategies for solving exponential and logarithmic equations. Today we'll start with a little bit of review and look at some equivalent forms of exponential equations. You should have realized by now that there's many different ways that we can represent a number in mathematics. For example, the number 4 can be written as 2 squared, or it can be written as the logarithm base 2 of 16. Or it can be written many different ways. 40 divided by 10, etc., etc., etc. So there's many different ways to represent a number in math using some of the different operators that we've learned so far. Today we'll be looking at this in more detail. So as an example, we'd like to express some different numbers as powers with a base of 2. Okay, and this really is review from grade 11. So as an example, the number 8 can be expressed as a power with a base of 2. 8 is the same as 2 to the power of 3. Okay, a little bit more complicated, the number 4 to the power of 3. If I want to express this as a power with the base of 2, I should realize that the number 4 is the same as 2 squared to the power of 3. And using the power of power rule, this is the same as 2 to the power of 2 times 3, or 2 to the power of 6. A more complicated example would be expressing the root of 16 times the 5th root of 32 to the power of 3 as a power with a base of 2. So using exponents, I can rewrite 16 as, I can rewrite the root of 16 as 16 to the power of 1/2. And I'm multiplying this by 32 to the power of 3/5. I can express 16 as a power with a base of 2. 16 is 2 to the power of 4 to the power of 1/2. 32 is the same as 2 to the power of 5, all to the power of 3/5. Again, I have an example of a power raised to a power. So I have 2 to the power of 4 times 1/2, all multiplied by 2 to the power of 5 times 3/5. And as I multiply, some things cancel out. And I'm left with 2 squared times 2 to the power of 3. When I have two powers being multiplied together that have the same base, I can add the exponents. So this ends up being 2 to the power of 5. Okay, final example, we want to express the number 12 as a power with a base of 2. And we actually can't do this just by inspection. 12 is not a power of 2. Okay, but we can think about it like this. Some number 2 to the power of k is equal to 12. And from what we did last unit, we can take the common log of both sides. So if I find the logarithm, the common logarithm of 2 to the power of k, set that equal to the common logarithm of 12, I can use my power law of logarithms to bring down the power of k. And then I can divide both sides by the logarithm of 2. And we don't want to evaluate this because that will give us an approximate answer, not an exact answer. So I'm going to leave it in exact form. And I can say that 12 is equal to 2 to the power of log 12 over log 2. As another example, getting a little bit more complicated, I can set up an exponential equation where my left-hand side and my right-hand side are not equal. And I can manipulate this in such a way to make them equal by solving for x. As a little aside, in grade 11 math, if I had some power raised to the exponent of a set equal to some power raised to the exponent of b, and the bases were the same on both sides, I could drop the bases and set the exponents equal to each other. And now we have the means to prove why this is true. If I take the common logarithm of both sides, and I use the power law to bring down my powers, I can then divide both sides by the common logarithm of x, the common logarithm of the base, and I'd be left with a equals b. So what we need to do in this question is manipulate this equation so that I have the same base on both sides. So I think my base of 4 is a good starting point because I can express 64 as 4 to the power of 3, which means I have the equation 4 to the power of x plus 5 equals 4 to the power of 3x. Now I'm in the situation where my bases are the same on both sides, so I can drop the bases. And I don't need to do this work to show it. And now I have an algebraic equation that I can just solve. 5 will be equal to 2x, which means x is equal to 5 halves. Okay, in my second example, I have the equation 4 to the power of 2x equals 8 to the power of x minus 3. I need to change the base on at least one side so that the bases are equal. But thinking about this, there's no way that I can express 8 as a power with a base of 4. And there's no way that I can easily express 4 as a power with a base of 8. But I do realize that 4 is the same as 2 squared, and 8 is the same as 2 to the power of 3. So now I have on both sides a power with a base of 2. So I can again drop the bases. And set the exponents equal to each other. And then I can solve this algebraic equation. So I have 4x equals 3x minus 9. Isolating x, I end up with x equals negative 9. Okay, so that ends our review video from what you did last year. We've built in a little bit of what we've been learning about logarithms this year. Tomorrow we're going to go a little bit further and look at some more complicated equations. Thanks for watching.